Hello, my name is Alan White, and I will be guiding you through our senior design project today. We are Group 7, which is composed of myself, Eddie Jasinski, Wesley Rumble, and Shannon Ramey. We will be showing you our software-defined radio and antennas. Behind me you can see the two antennas and one of the computers that we use to communicate wirelessly through the air, of course. So if you stick with us, we will show you the software component, the hardware component, and everything in between.
I'm Shannon Ramey. I'm a member of Group 7. The problem was to figure out a software-defined radio that we could use for such applications as mine rescue.
Other things such as extraterrestrial cave exploration and cave mapping, terrestrial cave mapping, or other applications.
We decided to use loop antennas because they're good for low frequency.
Hi, my name is Eddie Jasinski, and I'm going to talk to you a little bit about the software in our software-defined radio. We use GNU Radio as a test bed initially, but due to the limitations in the frequency hopping spread spectrum capabilities of the software radio, we had to switch to a phase shift keying implementation. And phase shift keying, you can see here how we encode the message sent. This is the encoding of the message. On the receiving end, the transmission is decoded and analyzed, and the message that was sent originally is displayed on the screen.
Hi, I'm Wes Rumble, and I'm going to talk to you about the hardware setup of our software-defined radio for Team 7. Real briefly, the signal that Eddie was talking about that takes the text message, sends it through the phase shift keying, turns it into tones, receives it on the other end, while the computers do the translating of the code and the text. The hardware we have is what sends it through the air. And what we have is a system of these loop antennas that we've built. I'm going to zoom in on one of these. The antennas are the same except for this preamp circuit on the receiver. The basis of the antenna, before we get into the preamp, all the antenna is, it's flexible conduit, and inside the conduit there's number 12 AWG wire. It's 15 turns inside, one continuous loop, and it comes and goes by this conduit box. So what happens on the transmitter is it comes out of the speaker port, transmits it through the antenna. This receiver receives the signal, comes out of the wires, and goes through this preamp circuit. Now the preamp circuit was designed to take the received signal and boost the voltage so that the receiving microamp, so that we can hear the tone for demonstration purposes, that the signal comes out at a very weak voltage out of the antenna. So the preamp was designed to step up the gain so that the amp and then the computer in turn can hear it. How we went about the preamp circuit, it is just a simple audio preamp. It's using an op-amp chip here, as you can see. It's an audio amplifier preamp chip, the LM386. There's some various capacitors that were different sizes were used. We ended up with the ones that we felt were the best for the gain that we were getting. According to manufacturer specs for the circuit, it's around 200 dB gain, which is pretty good, and it puts out a good tone, as you could hear in Eddie's segment when he transmitted. That was actually using the antennas. So at this point, without any power amplifier in the transmitter, we've been going at this distance of 4 feet. We had a power amplifier for transmitting, but it burned up, so we're just going at 4 feet for now due to lack of funds. So that's the basic hardware aspect of the project, and that's how it works.
We encountered a couple problems getting to this point, though. But we don't call them problems because most of them were just challenges. A couple of which revolve around, we had to pretty much, there's no support from the GNU community. It's a very active community, but it's largely a do-it-yourself sort of experience. And reaching out to various people resulted in a mixed bag of things, some good, some bad. Mostly nothing. Another problem that we had was with noise. And going from the computers, particularly in the mic in or line in for most of the computers, the circuits generated, or the board generated a lot of noise.
Some other setbacks that we encountered that we were able to overcome, as I previously mentioned, was the power amplifier system. We actually ended up having 2 amplifiers that met their demise in the project.
Smoke and flames.
Mainly due to the fact that you have to match your load to your amplifier. We tried to do that with adding some components to the loops, because the loops were measured at very low resistance, under 1 ohm. Most of the amplifiers were looking for a 4 to 8 ohm load of the typical speaker, and because of that, if you drive the gain too high, the amps blow up. And even though we put in some protection like a fuse in our second amp, it still did not work and it blew up. So, like I said, due to lack of funds, we've left it with this for the demo, which is fine because our demo space is somewhat restricted anyway. So, that's what we have.
Other problems that we encountered, frequency hopping spread spectrum is, well, we'd have to write our own protocol to drive a GNU radio. It currently does not exist. There isn't a module for it. And writing one wasn't within our grasp, given the timeline and the monetary constraints. The USRP is a hardware component that's used in conjunction with GNU radio, and it's very expensive, more so than the budget of this project. But we accomplished what we could with off-the-shelf hardware. Much of it, all of it, at no cost to the university. Just a couple of computers, some wire,
All of the wire in the antennas was salvaged from abandoned power cords, and the conduit was purchased by the team, but it was minimal cost, under $10, which was not didn't warrant a purchase order. Everything else was just not, I won't say scrap. It wasn't scrap, but it was just stuff that we had laying around.
In conclusion, we feel that we have a good prototype for a software-defined radio.
And also with the right hardware and amplification, we feel that we could get large distances through rock with the hardware that we've got.
We tested the prototype through various mediums, such as the walls in this room, through brick walls at the engineering building, and actually through the floor from the 9th floor down to the 8th floor at one point, and transmitted music, because we couldn't hook up the laptops on the move like that. But with an iPod and the small receiver, it transmitted through the rock no problem. It was exactly like it was in the room at that same distance. In addition to a power amplifier also, if we had more wire and bigger conduit, the bigger the loop and the more turns, we feel like that would add to the propagation as well in the distance.
What we sought out to do is send some form of communication from point A to point B. While it's not up to 1,000 feet, which was in our original proposal, things change when it comes to development from planning, and that just happens to be one of them. But we still have a project, hardware, software, and a whole bunch of plastic that does the spirit of what we set out to do.